In this lesson, we're going to be looking at radian measure, which is a way to measure angles differently than in degrees. So by the end of this lesson, you should be able to define a radian and convert measurements in degrees to measurements in radians. Just like there are different units to measure lengths, there are different units for measuring angles. So far, we've measured angles in degrees, where a full circle has 360 degrees. Now, we're going to learn about radians. Radians are similarly defined in terms of a circle. So the definition of a radian. One radian represents an angle where the arc length is equal to the radius. So the first blank that we're putting in here is equal. So if we have the radius r, then 1 radian is the angle that makes this arc length right here also equal to r. So that angle that makes this arc length equal to the radius of the circle is 1 radian. Radians are defined as the ratio between the arc length a and the radius of the circle. And since radians are a ratio, they are unitless. Okay. So typically we say like this many radians, but there's no actual units. Whereas with degrees, there is the degree unit. This is given by the following formula. So you can use this formula to calculate what a radian is. It's the ratio of the arc length over the radius of the circle. So if we take a look at the following, these are just calculations of how to find radius using the basic, how to find radians using the basic definition of a radian, which is arc length over radius of the circle. So if we wanted to find here, okay, so we've got theta is equal to a over r. This question's asking us to find a. We have 2 radians and the radius is 6. So we can substitute 2 radians. Arc length we don't know, and the radius is 6 centimeters. Multiply both sides by 6 centimeters. Which will clear the 6 centimeters from the bottom, and we get 12 centimeters is equal to the arc length. In this case right here, we are trying to find the radian measure, and the radian there is this big angle here. So it's nearly 360 degrees. So we have to find how many radians that is. Okay. So theta is equal to, and they give you the arc length in this case. The arc length is 45 centimeters. The radius is 10 centimeters. Notice that the units cancel, right? We get 4.5 for radians. So radians is equal to 4.5. Okay, in this question here, we're looking for the radius, and they give you the arc length and they give you the radians. So the radians is 3.2, arc length is 28 centimeters, all over the radius. What I'm going to do is I'm going to take the radius and multiply it by r on both sides. Okay, and so then I get 3.2r is equal to 28 centimeters. And then r should just be equal to 28 centimeters divided by 3.2. Okay, and then we can do that calculation. So 28 divided by 3.2. So r is equal to 8.75 centimeters. Okay. So you notice here that the arc lengths have a unit, right, as they should, but the angle does not have a unit because it's in radians. Radius has a unit, as it should, it's a measurement, but the angle here, 3.2, is unitless because it's in radians. Okay, so the whole part of, the whole point of this portion of the lesson is just to use the basic definition of radians to calculate things like the angle, the arc length, or the radius of the circle in question. So we're going to look at what the relationship is between degrees and radians. So we consider a circle drawn to the left. So if this angle, see this arm right here, has gone around in a full circle, you don't have to draw these arrows, so say it's gone around in a full circle, then we would say that the angle has undergone one full revolution, and if the angle has gone around one full revolution, that's equal to 360 degrees. Right, I'm just going to erase those arms here. So we've gone 360 degrees. Okay, if we do 360 degrees, right, then what is A? What is the arc length if the angle has undergone one full revolution? Well, the arc length would trace this entire perimeter of the circle. Okay, so if theta is 360 degrees, then A is equal to the circumference. Right? That's the perimeter of the circle. The arc length is just the circumference. And so the formula for circumference is 2 pi r. Okay? So if we do a full 360 degree rotation, then A is the perimeter of the circle. That just means circumference, and there's the formula. So let's use the formula for radians here. Theta is equal to A over r. Well, we said that A is equal to 2 pi r, and therefore divided by r, well, we can see that the r's will cancel. So 360 degrees, therefore 360 degrees is just equal to 2 pi, right? So a full revolution, right, 360 degrees was 2 pi r over r, so that means 360 degrees is equal to 2 pi because the r's cancel. So if we have 360 degrees equal to 2 pi, I can simplify that by dividing both sides by 2, and then I get my final conclusion. So my final conclusion is that 180 degrees is equal to pi radians. So 180 degrees is just equal to pi. This allows me to then represent common angles in other ways, right, in radians. So for example, 30 degrees in radians is equal to pi over 6. 45 degrees is equal to pi over 4. 60 degrees is equal to pi over 3. 90 degrees is equal to pi over 2. And then we have 180 degrees is equal to pi, or also you could say, if you wanted, we already talked about this, 360 degrees is equal to 2 pi. So these are very important angles to remember, because when we do, or when we study rotational trigonometry and trigonometric functions, these are the important angles to consider. So 180, 360, so pi and 2 pi, then 30, which is pi over 6, 45, pi over 4, 60, pi over 3, 90, pi over 2. In grade 12, we will exclusively be working in radians. So we will not be working in degrees anymore. The expectation is to work exclusively in radians. Now, if you absolutely need to, you can convert degrees to radians by multiplying by pi over 180, or radians to degrees by multiplying by 180 over pi. However, the expectation is to be able to think about this in a more sort of holistic way, or looking at it in terms of just the number of degrees there, right? So what I mean by that is 4 pi over 3. Well, what's the degrees? Well, instead of going 4 pi over 3 times 180 divided by pi and having to input that in your calculator, you can just think of it as follows, okay? 4 pi over 3s. Well, if I have 4 pi over 3s and pi over 3s is 60 degrees, then I have 4 60 degrees. Right? Because pi over 3, I'll remember that that is 60 degrees. So 4 pi over 3 is just equal to 4 60 degrees, or 4 times 60 degrees, and that's equal to 240 degrees. Okay. Similarly, if you look at radians here, right, so 150 degrees to radians, well, 150 degrees, right, is the same thing as thinking about, okay, well, that would just be like 5 times 30 degrees, right? That's 150 degrees. You try and think about it in terms of these special angles here, right? Because these special angles relate to very specific radians. So 30 degrees is equal to 5 times, and 30 degrees is pi over 6. So 5 pi over 6s, so 5 pi over 6. So this is eventually the way you want to be thinking to be particularly advanced when it comes to using radians. Now, if you are very uncomfortable with radians and you're in a complete pinch here, then absolutely you can just do this on your calculator every time. I will say though that this is going to take you some time, and this is the preferred method way, or the preferred way of thinking about it. Okay, so that would be 240 degrees once you input that into your calculator. Alternatively, you could do 150 degrees multiplied by pi over 180 degrees, and you would get 5 pi over 6. Okay, so ideally, and you see here that we don't actually, we don't report this as a decimal. We are using exact values here, okay? A wheel spins at a rate of 200 revolutions per minute. Determine the angular velocity of the wheel in radians per second, and note that angular velocity is the speed at which the angle changes. So we're looking at how many radians, or the change in radians per second. So if we have 200 revolutions per minute, so I'll write this, 200 revolutions for every 1 minute. That's given in the question. I know that 1 full revolution is equal to 2 pi radians, right? So 1 revolution is 360 degrees. But again, we're moving away from using degrees, and we're thinking about it in terms of radians. So 1 revolution is equal to 2 pi. So knowing that I have to cancel revolutions, I put revolutions on the bottom. So 1 revolution is 2 pi radians. Okay, so I cancel revolution because it's top and bottom. All right, but this is 2 pi for every minute, right? And I think the question is asking me to do it for every second. So I need to get rid of minutes, and I say, okay, for every 1 minute, there are 60 seconds. So that would allow me to then cancel out minutes and minutes. And I end up with 400 pi for every 60 seconds, which can be reduced to 20 pi radians over 3 seconds, which is approximately equal to 6.7 radians per second. Okay, so just to review what was done on this page, we looked at the relationship between degrees and radians, and we ultimately came up with the conclusion that 180 degrees is equal to pi radians, or 360 degrees is equal to 2 pi radians. And then I listed off these very important angles, right? Now, these are very important. You should know these. You're going to be using them again and again throughout this unit and throughout the next unit. And we're going to exclusively be working in radians here. To convert, I emphasize that the important way of, or really the advanced way of looking at this, is taking this fraction and splitting it up. 4 pi over 3 just means 4 pi over 3's, so 460 degrees, that's 240 degrees. Okay, that's a quick way of going about it. Alternatively, you can use the conversion factor. You think about 150 and try to think about 150 in terms of these angles. Well, 150 is the same thing as saying 5 times 30, so 5 pi over 6. Okay. Alternatively, you could do 150 times pi over 180, but you would actually, in this case, to get the exact value, you would have had to have reduced. You would have to okay, well, the zeros cancel, and then I've got 15 over 8. Well, I'm going to divide both sides by 3, so I get 5, and therefore 6, so 5 pi over 6. So you'd still have to do some work there, right? Okay. The last thing is we looked at a problem that wanted us to do how many degrees per second or how many angle changes per second. And instead of looking at it in terms of degrees, we looked at it in terms of radians. And we recognized that 1 revolution was 2 pi radians. And then we used our conversion factors to determine the angular velocity. Okay, so this was just a review of radians right here. You should have seen some of this in grade 11 as we looked at it ahead of time, but alternatively, by looking at it through this lesson, you should be prepared for subsequent lessons that deal exclusively in radians. As always, thanks for watching.